Hi everyone, welcome back. We're going to go ahead and get started with the substitutions and algebra associated with this problem. So let's just get right into it. We always want to remember that our main equation is the rate law for the rate determining step. So everything else that we worked on in the first video, all of the rate law equations for the fast steps are all going to be substituted into this main one because it's the slowest step. It determines the overall rate of the overall reaction, which is indicated in hot pink here. And we're trying to see if this is a viable mechanism for this reaction. So the first thing that we notice is that we have an intermediate here, like we talked about in the last video. So that intermediate shouldn't be in our overall rate law once we're done with all of this. So we want to first substitute something into or in place of E so that we can start getting rid of intermediates. So we're going to look for a rate law that we wrote in the first video that has E in it, so we can solve for E and substitute it into this overall rate law. So the only rate law expression that we have for all of the fast reactions that contains E is this first rate law here. And it's on the right side of that equation. So what we're going to do is we're going to take, and I'll just copy it from here. We're going to take this expression, and I'll get a fresh page. We're going to take this expression for that first rate law, and since we want to plug it in to our overall rate law for E here, we have to isolate it first because that's what we're trying to get rid of. So the way that we're going to do that is, so we want it all by itself. So we have to get rid of this rate constant, the concentration of C, and the concentration of G. So the way that we're going to do that is divide this entire side by those variables. And then remember our general algebra rules. Whatever we do to one side of an equal sign, we have to do to the other side. So we're also going to divide the left side of this equation by the same thing. And what this turns into is we have E, the concentration of E on the left side, and it's equal to K1 times A squared times F all over K minus 1 times C times G. So now we've isolated E here, so then the next step is plugging all of this that's equal to E back into our rate determining rate law here. So, and that is the rate is equal to K5 times concentration of A times the concentration of E. So now, and I'll just do this in another color, all of this will be substituted in for E. So when we write that out, our rate then becomes K5 times the concentration of A times K1 times the concentration of A squared times the concentration of F, and all of that is over K minus 1 times the concentration of C times the concentration of G. And now we can simplify this a little bit because we have an A here and an A squared here. So we're just going to combine those So we have K5, and then I'm going to bring the K1 just over a little bit. It's still all multiplied together, times A now to the third power, times F, that's all over K minus 1 times C times G. So this is now our new rate equation. So instead of going back up and using this rate equation, now we're going to start using this as our rate equation because it's the updated version. So now we've gotten rid of E. We don't have to worry about E as an intermediate in our rate law, but we do now have to worry about F, G, and C, because F and G here are also intermediates, just like E was, and C is a product of our reaction. So neither of those should be in our rate laws, but we want to just do this step by step. We're not going to be able to take care of them all at the same time, but we'll deal with first the intermediates. So my recommendation is to start by isolating and substituting in for the intermediates and then work on the products, just so that you have a little bit of a priority list there to focus on. And because we want to try and make this as simple as possible without doing tons and tons of algebra, we're going to see if we can find an equation where we have F and G together. Because that would be really convenient if we could just substitute for both of them rather than F first and then G, or the other way around. So we're going to come back up to our list of rate equations and look for where we see F and G in the same rate law. So we've already used this first one. And what you'll notice is that in this fourth mechanism step right here, we have both G and F. And it's okay that they're on different sides of the equation, because we will eventually get them on the same side of the equation once we do a little bit of manipulating. So this step 4 equation is now what we want to use to isolate even more intermediates and get those out of our updated rate law. So I'm just going to take our 4th step and copy it down here. Okay, so this is our rate law from step 4, and I had said just a minute ago that we want to try and get rid of F and G together. So what we're going to do is we want to try and match how they appear in our rate law, because that will make the substitution the easiest. So we're going to try and isolate F divided by G. So we have F here, and if we want to divide it by G, that means that we are